There is a document buried inside the archives of NASA's own publication history that has never been formally retracted. It was written by two of the agency's own scientists. It appeared in a peer-reviewed journal, and it proposed something so far outside the boundaries of acceptable scientific conversation that the men who wrote it effectively vanished from mainstream academic discussion shortly after it was published. The document proposed that the moon is not a natural object, that it was in fact constructed, that something put it there, intentionally, with a purpose that had nothing to do with creating ocean tides or lighting the night sky for human poets to romanticize about. And here is what makes that document extraordinary beyond even its own audacity. The ancient Sumerians, writing on clay tablets more than 5,000 years ago, in a civilization that had no telescopes, no orbital mechanics, no spectral analysis, said the same thing. Not approximately, not metaphorically, the same thing. And the astronauts who walked on the surface of that object, or flew around it, or monitored it from orbit, came back to Earth and said things in press conferences and interviews and private conversations that their employers at NASA have spent decades trying to explain away, contextualize, or simply ignore. This is not a fringe theory assembled from wishful thinking and late-night radio shows. This is a convergence. A convergence between the oldest written records in human history, the testimony of men who were actually there, and the data that continues to accumulate from every lunar mission launched in the last 60 years, including missions by space agencies that have no particular political loyalty to the story NASA has been telling. We are going to go through 7 of these convergences, one by one, with the kind of specificity that does not allow for comfortable dismissal. By the time we reach the 7th, you will understand why the question is not whether the Sumerians knew something about the moon that we have been discouraged from knowing. The question is how they knew it. And who told them? Before we get into the specifics, we need to spend a moment inside the world that produced these tablets, because the dismissal of Sumerian knowledge as primitive mythology is one of the most strategically convenient intellectual moves in the history of modern academia. The Sumerians did not think of themselves as storytellers. They did not have a tradition of mythology in the way that word is used today, meaning entertaining narratives invented to explain natural phenomena to uneducated populations. The Sumerians had a tradition of record-keeping. They were, by every archaeological measure, the most administratively obsessive civilization in human history. They kept records of grain shipments. They kept records of property disputes. They kept records of astronomical observations stretching back thousands of years before their own writing emerged, records they claimed to have inherited from predecessors who existed before the Great Flood that is referenced in their texts and in every other ancient tradition on Earth. When they wrote about the moon, they were not composing poetry. They were filing a report. The tablets that concern us most are not the ones that get discussed in university courses on ancient religion. Those tablets, the ones about Enlil and Enki and Nanna and the great assembly of the gods, those are the ones that get filtered through the lens of comparative mythology and reduced to primitive attempts at explaining thunder and rain and the seasons. The tablets that concern us are the ones that were written in a register that Sumerian scribes themselves marked as a different category of information entirely. They used a designation that translates most accurately as something like true account or witnessed record, a distinction from the narrative compositions that surrounded it. These tablets describe, in technical language that has no business existing in a 5,000-year-old document, specific characteristics of the moon that were not confirmed by modern science until the 20th century. 7 of those characteristics converge with things that the people who have actually been to the moon, or in its vicinity, refuse to discuss openly. Let us begin. The first convergence concerns the interior of the moon. What is inside it? This is a question that modern planetary science has been quietly struggling with since 1969, because the answer that keeps emerging from the data does not fit the story that was supposed to be true. The story that was supposed to be true is that the moon formed approximately 4.5 billion years ago when a Mars-sized object collided with the early Earth, and the debris from that collision coalesced into the object we see in the sky every night. This is called the giant impact hypothesis, and it is the dominant scientific model for lunar formation. Under this model, the moon should have a composition broadly similar to Earth's mantle. It should have a substantial iron core, because the material that formed it came from a planet that had already differentiated, meaning its heavy elements had already sunk to the center. It should ring, when struck, the way a solid, rocky body rings. Short and dull, like hitting a boulder with a hammer. That is not what happened when NASA struck the moon. On the 20th of November 1969, after the Apollo 12 astronauts returned to their command module, the lunar module they had descended to the surface in was deliberately crashed back onto the moon. The impact was equivalent to detonating roughly 1 ton of TNT on the lunar surface. NASA had placed seismometers on the surface specifically to record what happened next. What happened next was that the moon rang like a bell, not like a boulder, not like the solid rocky body that 4.5 billion years of planetary formation should have produced, like a bell. The ringing continued for more than an hour. Some accounts from the scientists monitoring the seismometers describe it as continuing for nearly 2 hours. The technical term used in the subsequent papers was reverberations, but the seismologists who were actually reading the data in real time used a different word in their recorded conversations. They said it was hollow. Not hollow like an empty sphere. Hollow like a structure that has internal chambers or layers of varying density arranged in a way that produces resonance rather than absorption. The moon did not absorb the seismic energy of the impact. It transmitted it and amplified it in patterns that no model of a naturally formed planetary body could predict or explain. This result was so unexpected that it was repeated. Apollo 13's Saturn V third-stage rocket, weighing more than 14 tons, was also deliberately impacted onto the lunar surface in April of 1970. The seismometers left by Apollo 12 recorded the result. The moon rang again, for more than 3 hours. The reverberations were so strong and so prolonged that the scientists analyzing them later described the signal as unlike anything produced by any known natural body in the solar system. Apollo 14, 15, 16, and 17 all contributed additional impact data, either from discarded equipment or from deliberate crash tests, and every single impact produced the same anomalous result: prolonged, resonant ringing that should not occur in a solid, rocky body. The two NASA scientists who took this data seriously enough to follow it to its logical conclusion were Dr. Mikhail Vassin and Dr. Alexander Sherbakov. They were not, as is sometimes claimed, fringe researchers operating outside legitimate institutions. Vassin was a member of the Soviet Academy of Sciences. Their paper, titled "Is the Moon the Creation of Alien Intelligence?" was published in 1,970 inches, the Soviet journal Sputnik, which was a mainstream science publication, not a speculative one. In that paper, they argued, based on the seismic data and on a series of other anomalies we will get to in a moment, that the moon's extraordinary resonance could only be explained if its interior was not solid rock but rather a hollow or semi-hollow structure, with an outer shell of considerably greater strength and density than naturally formed lunar rock should possess. They propose that the object in our sky is, in essence, a spacecraft, an ancient one that was placed in its current orbit deliberately, by intelligence, for purposes that they could only speculate about. Now here is where the Sumerian record enters the picture, and here is where the word convergence stops being a polite academic term and starts being something more unsettling. The Sumerian texts that describe the moon, particularly the texts associated with the deity called Nanna, who is the Sumerian name for the moon, contain passages that describe the interior of the moon in terms that have no business being in a document written in the 3rd millennium before the Common Era. The tablets describe Nanna's domain as hollow within, as containing chambers that resonate with the movements of the cosmic waters, as having an inner world that is separate and protected from the outer surface. This language, when read through the lens of comparative mythology, gets translated as poetic description of the moon's phases, or the reflected light of the sun. But the Sumerian scribes who wrote in that marked category of witnessed record did not use poetic register for technical descriptions. They used a precise administrative vocabulary. And the precise administrative vocabulary they used to describe the interior of the moon describes, without ambiguity, a hollow structure with internal chambers. The Anunnaki texts, particularly those that describe the moon as a vessel used for transit between what the tablets call the heavens and the earth, contain descriptions of the moon's interior that include references to what translates most accurately as the bones of the skyship, a metaphor that has been rendered in academic translations as cosmic mythology, but which, when examined in the original cuneiform, uses the same root word that Sumerian scribes used when describing the structural supports of actual buildings and actual boats. This is not a minor linguistic point. The Sumerians had a clear distinction between language used for stories and language used for structural description. They used structural description language when talking about the interior of the moon. The astronauts who walked on the moon did not talk about its interior in official press conferences, and this is itself a data point worth examining. What they did talk about, in the unguarded moments that have been preserved in recordings and transcripts, tells a different story. Edgar Mitchell, the Apollo 14 astronaut who walked on the lunar surface in February of 1971, spent the last decades of his life giving interviews in which he said, with increasing directness as he aged, that the information that came back from the lunar missions was not fully shared with the public. He did not specify what that information was. He was not in those interviews talking about his famous experiences with what he described as contact phenomena during the return journey. He was talking about the moon itself, about its nature, about what the data showed and what was decided at levels above the astronaut corps, about what to do with that data. Neil Armstrong himself, in a conversation that was recorded but which NASA has consistently described as informal and therefore not representative of official findings, described the moon as an extraordinary object, not in the way a geologist describes an interesting rock formation, in a way that suggests he encountered something on that surface that he was processing in terms that went well beyond the training he had received for what he was supposed to find. The specific conversation has been cited in multiple books and investigative articles, and NASA has never denied that the conversation occurred, only that it has been taken out of context. When asked what context would make Armstrong's words less remarkable, NASA has not provided one. We will come back to the astronaut testimonies throughout this presentation, because each of them connects to a specific Sumerian fact in ways that compound the strangeness rather than dissolving it. But the first fact is the one that underpins everything else. The moon rings like a bell because it is hollow, or structured in a way that produces the acoustic signature of a hollow object. The Sumerians described the moon as hollow, using structural vocabulary. The scientists who analyzed the seismic data from 6 Apollo missions arrived at the same conclusion using completely different methods 5,000 years later. And the men who were actually on the surface came back and said things, in unguarded moments, that suggest they understood they were standing on something that did not fit the category of natural planetary body. That is the first convergence. It does not get more comfortable from here. The second convergence requires us to talk about mathematics. Specifically, about the mathematics of the moon's orbit and its size relative to the sun, and about why both of those numbers are so precisely wrong that the probability of them occurring by natural chance has been calculated by actual astronomers and found to be, in the most generous estimates, vanishingly small. This is a conversation that tends to make astronomers uncomfortable, not because they disagree with the numbers, which are not in dispute, but because the implications of the numbers are something that mainstream science has no satisfying framework for addressing. The Sumerians, however, addressed it directly. They addressed it in a way that suggests they understood not just that these numbers were significant, but why they were significant, and who had arranged them. Here is the mathematics, stated as plainly as possible. The sun is approximately 400 times larger in diameter than the moon. The sun is approximately 400 times farther from Earth than the moon. As a result of these two ratios being essentially identical, the moon appears from Earth's surface to be almost exactly the same size as the Sunday, not approximately the same size in a rough general sense. The same size to a precision that allows for what astronomers call a perfect total solar eclipse, in which the moon's disk covers the sun's disk so precisely that only the sun's corona, its outer atmosphere, remains visible. This phenomenon is unique in the known solar system. No other moon around any other planet in our solar system produces a perfect total eclipse of its parent star. The mathematical precision required for this to occur is extraordinary, and it does not end there. The moon's orbital period, the time it takes to complete one orbit around Earth, is 27.3 days. The moon's rotational period, the time it takes to complete one rotation on its own axis, is also 27.3 days. This is called tidal locking, and it is the reason the moon always shows the same face to Earth, the reason there is a near side and a far side, and the reason humans did not know what the far side looked like until spacecraft photographed it in 1959. Tidal locking is not unique to the moon. Many large moons around other planets are tidally locked to their parent bodies. What is unusual about the moon's tidal locking is the precision of it, the fact that the rotation period and the orbital period match so exactly that the moon's libration, its slight wobbling that allows us to see slightly more than 50% of its surface over time, is itself precisely calibrated to reveal specific features at specific times, in ways that have prompted serious researchers to wonder whether it was designed to do so. The moon's orbital inclination relative to Earth's equatorial plane varies between approximately 18 and 28 degrees over a roughly 18-year cycle called the Metonic cycle. This cycle was known to the ancient Babylonians, who inherited their astronomical knowledge from the Sumerians, and was used to predict eclipses with extraordinary accuracy. The Metonic cycle is not a coincidence of orbital mechanics. It is a precisely measurable, precisely periodic pattern that results from the interaction of the moon's orbital parameters with the sun's gravitational influence. And the parameters that produce it, the specific values of the moon's orbital inclination and eccentricity, and the ratio of its distance from Earth to the sun's distance from Earth, are all so precisely calibrated relative to each other that the mathematician and researcher Dr. Alexander Thom, who spent decades surveying ancient megalithic structures, concluded that the ancient peoples who built Stonehenge and the alignments at Karnak were tracking the metonic cycle with a sophistication that implies they had been taught to do so, not that they had figured it out independently over generations of naked-eye observation. The Sumerians had a word for the mathematical precision of the moon's orbital arrangement. It was a word that also appears in context describing the precision of engineered structures, the alignment of temple walls with celestial bodies, the calibration of instruments used in construction. The word has been translated variously as ordained, fixed, or decreed, but what it means in its original administrative context is set to specification. When Sumerian scribes used this word in relation to the moon's position and its relationship to the sun, they were not describing a natural arrangement that they happened to notice. They were describing an engineered specification that had been implemented by entities they called the Anunnaki, whose name translates most directly as those who came from the sky to earth, or in some interpretations, those who from the heavens to earth descended. The Anunnaki texts describe the moon's placement in its current orbit as a deliberate act undertaken for specific purposes that the tablets enumerate with a specificity that is deeply uncomfortable for anyone who has read them while also being familiar with the orbital mechanics data. One of the stated purposes, described in what scholars call the Enuma Elish, the Babylonian creation epic that is itself based on older Sumerian source texts, is the regulation of time. The moon was placed in its orbit to create a system of time measurement that could be observed and understood by the human beings the Anunnaki had created. Not discovered by those human beings over generations of careful observation, provided to them as a given system, pre-installed in the sky, ready to use. The tablets are explicit about this. The moon is not described as a natural object that humans learned to use for timekeeping. It is described as a timekeeping instrument that was placed in the sky for human use, by someone else. The distinction matters enormously. The astronaut conversations that connect to this second convergence are not about orbital mathematics directly. They are about the moon's surface, and what the astronauts found there that suggested the object they were standing on had a history that did not match the history that planetary science expected it to have. But one conversation in particular, one that has been cited repeatedly in investigations of NASA's relationship with anomalous lunar data, touches on the question of the moon's orbital precision in a way that is worth examining carefully. It involved not an astronaut, but one of the senior scientists in the Apollo program's scientific advisory structure, a man who held multiple advanced degrees in geophysics and who, after leaving NASA, gave a series of interviews in which he described a conversation among senior scientists in which someone raised the question of whether the moon's orbital parameters could have occurred naturally. The answer given, according to this scientist, was not yes. The answer given was that the question should not be pursued in that direction. What direction should it be pursued in? He was not told. He was told that the team's job was to characterize the lunar environment, not to theorize about its origin. This kind of institutional closure around certain categories of questions is not unique to NASA. It appears in the records of every major space agency that has conducted serious lunar research, and it follows a pattern that is consistent with the existence of information that has been received, processed, and then sequestered from the public scientific conversation. The pattern is not a conspiracy in the dramatic sense. It is bureaucratic. Someone at some level in the institutional structure decided that certain findings should be categorized in a way that removes them from public circulation. And the machinery of classification and compartmentalization that exists in every government-adjacent scientific institution did the rest. The people who carried out the work often did not know what happened to the more anomalous data they generated. They filed their reports and moved on to the next task. The reports went up the chain. Some of them did not come back down. What the Sumerians understood about the moon's mathematical precision, and what they said about who produced that precision and why, is a record that predates all of that institutional machinery by 5,000 years. It cannot be classified. It cannot be sequestered. The tablets exist in museums on multiple continents, translated and published and available to anyone who wants to read them. What is missing is the willingness to read it in the register in which it was written, not as mythology, as a report. The precision of the moon's orbital parameters, the size ratio with the sun, the tidal locking, the metonic cycle, the perfect geometry of total solar eclipses, These are not accidents. They are not random outputs of a chaotic planetary formation process that happened to land on a convenient arrangement. The probability calculations that have been done by researchers working within mainstream institutions as well as outside them consistently return numbers so small that the word coincidence becomes statistically meaningless. The Sumerians did not have probability calculations. What they had was direct testimony from entities that they identified as the architects of the arrangement. And what those entities apparently told them was this: we put it there, we set it to specification, and the specification was precise, because precision was the point. The second convergence is mathematical. It is verifiable, and it is waiting for anyone willing to look at it honestly. The third convergence is about the surface of the moon. Specifically, about what the moon's surface is made of, and about the extraordinary material properties of that surface that continue to defy the explanations that mainstream planetary science has offered for them. This is where the astronaut testimonies become most specific, because unlike the seismic data, which was processed by instruments and analyzed by scientists in laboratories, the surface of the moon was touched directly by 12 human beings. And several of them said things about what they found there that their mission debriefings were apparently designed to minimize. The Sumerian tablets, for their part, described the surface of what they called Nanna's vessel in terms that match the anomalous material data with a precision that is either the most extraordinary coincidence in the history of human knowledge, or it is something else entirely. The first thing to understand about lunar surface material is that it is wrong. Not wrong in the sense of being mislabeled or misidentified, but wrong in the sense that it does not have the composition that it should have if the moon formed the way the dominant hypothesis says it formed. The giant impact hypothesis predicts that lunar material should be broadly similar to Earth's mantle material, with some depletion of volatile elements due to the heat of the impact event. What the Apollo missions actually retrieved and brought back to Earth was something considerably more complicated. The lunar regolith, the layer of pulverized rock and dust that covers the lunar surface, contained minerals and elements in concentrations that, in some cases, simply should not have been there at all. Among the most anomalous findings was the presence of titanium in concentrations far higher than any natural lunar formation process should have produced. Titanium is an extremely refractory element, meaning it requires very high temperatures to work with, which is relevant because titanium's primary commercial applications involve its extraordinary strength-to-weight ratio and its resistance to corrosion and heat. When researchers analyzed the lunar samples, they found that certain strata of the lunar crust contained titanium concentrations more than 10 times higher than anything found in Earth's crust or in any known class of meteorite. Some of the samples contained concentrations that, if found on Earth, would constitute commercially viable titanium ore deposits. On the moon, they constitute a mystery that no natural formation process has been able to adequately explain. The presence of pure metallic iron in the lunar regolith is another anomaly that tends to get quietly passed over in mainstream discussions of lunar geology. Metallic iron, meaning iron in its unoxidized elemental form, rather than as part of an oxide mineral compound, does not persist naturally in environments that have experienced any significant geological activity over billions of years. On Earth, metallic iron in the crust is essentially always either from meteoritic material, meaning it was delivered by impacting space rocks, or from industrial processes. On the moon, which has no atmosphere and has not had active geological processes for at least 3 billion years, the presence of metallic iron particles scattered throughout the regolith has been attributed to micrometeorite impacts that delivered the material. But the distribution and quantity of the metallic iron, as well as its specific isotopic ratios, do not match what delivery by micrometeorite would predict. Some researchers examining this anomaly have noted that the distribution pattern is more consistent with material that was processed and then distributed across the surface than with material that was delivered randomly from space. The Sumerians described the outer shell of Nanna's vessel using language that translates as the shining metal of the sky, a phrase that academic translators have generally rendered as a poetic description of the moon's reflective appearance in the night sky. But the specific cuneiform signs used in that phrase are not the signs that Sumerian scribes used for poetic or descriptive language about light and reflection. They are signs used in metallurgical contexts. The same signs appear in Sumerian texts that describe the processing of metals in what the tablets call the Great Forge of the Anunnaki, and in descriptions of the materials used in the construction of structures that the tablets describe as existing in the heavens. When a Sumerian metallurgical scribe used the phrase shining metal of the sky in a witnessed record context, he was not writing a poem about moonlight. He was describing a material. The Atrahasis epic, one of the oldest Sumerian narrative texts that also contains sections written in witnessed record register, describes the exterior of the moon using terms that include words for refined, processed, and layered. Three terms that, taken together, describe not a naturally occurring surface, but a manufactured one. The tablets describe the outer surface of Nanna's domain as having been made through a process, not as having formed through natural accretion. This distinction is not subtle in the original cuneiform. The Sumerians had different verb forms for things that happened naturally and things that were made by intentional action. The verb forms used in descriptions of the moon's exterior surface are in the category of intentional manufacture. Harrison Schmitt was the only professional geologist to walk on the moon. He was on Apollo 17, the last mission, in December of 1972, and he spent more time doing actual fieldwork on the lunar surface than any other Apollo scientist. He collected samples, documented geological features, and made observations that he communicated in real time to scientists on Earth. He has also, in the decades since Apollo 17, been one of the more forthcoming of the Apollo astronauts about the anomalous aspects of what he encountered. Not in dramatic terms. In the careful, precise language of a scientist who has been thinking about something for a long time and has concluded that honesty requires acknowledging that certain things did not fit the models. Schmitt has described the concentration of titanium in certain lunar samples as extraordinary, a word he has used in contexts where it is clear he does not mean extraordinary in the sense of wonderfully impressive, but in its older sense of outside the ordinary, outside what the ordinary models would predict. He has noted, in technical papers and in less formal contexts, that some of the material properties of lunar surface samples remain unexplained decades after they were collected and analyzed. Not underexplained. Unexplained. The broader category of anomalous lunar surface materials includes several other elements and compounds that have received less public attention than titanium but are no less problematic for natural formation models. Uranium and thorium concentrations in certain lunar surface samples are higher than would be predicted by any standard planetary formation model. Neptunium, 237, a transuranic element that does not occur naturally in meaningful quantities anywhere in the solar system, has been reported in trace amounts in some analyzed samples, though this finding has been subject to sufficient controversy that mainstream sources treat it with considerable caution. Processed particles of chromium, ytterbium, and beryllium have been identified in lunar regolith samples in forms and concentrations that, on Earth, would indicate industrial processing, rather than natural geological formation. Each of these individual anomalies can be attributed, with sufficient creativity, to some exotic natural process. The problem is that taken together, they describe a surface that has been worked on, processed, modified from whatever its natural state might have been into something that looks more like the output of an industrial operation than the output of 4 billion years of quiet geological cooling. The Sumerian texts that describe the Anunnaki's relationship with the moon include passages about what the tablets describe as the working of the sky metal, processes undertaken by the Anunnaki on the surface of Nanna's vessel that involve the transformation of materials found there into materials useful for purposes the tablets do not fully specify. Academic translators, when they engage with these passages at all, rather than simply categorizing them as mythological elaboration, typically interpret them as descriptions of the Anunnaki working in their heavenly workshops, producing the divine tools and weapons and ornaments that appear throughout Sumerian mythology. But the specific technical vocabulary used in those passages, the verb forms for industrial processing, the nouns for refined and layered materials, the descriptions of the outer shell of Nanna's domain as distinct from what lies beneath it, all of this is consistent with a description of an industrial operation conducted on the surface and subsurface of the moon, not metaphorically, literally. In the precise administrative witnessed record register that Sumerian scribes used when they were describing things that actually happened. This is the third convergence, and it is perhaps the most materially verifiable of the 7. The anomalous material composition of the lunar surface is not a matter of interpretation or speculation. The samples are in museums and laboratories. The analyses have been published in peer-reviewed journals. The anomalies are acknowledged, even if their explanation is perpetually deferred. The Sumerian description of those anomalies, encoded in 5,000-year-old cuneiform using metallurgical vocabulary rather than poetic vocabulary, is equally accessible and equally factual. The connection between them requires only the willingness to read both sets of records honestly, without the pre-commitment to naturalistic explanation that has characterized mainstream lunar science since the Apollo missions returned their extraordinary, anomalous, deeply uncomfortable data, and the institutional machinery set quietly to work deciding what to do with it. The fourth convergence takes us into territory that is, in some ways, even more disquieting than the first three, because it involves not just data and ancient texts, but the actual behavior of the men who were sent to the moon and what happened to their psychology when they came back from it. This convergence concerns what the Sumerians described as the Watchers, the function of the moon as an observation post, a station from which those who operated it could monitor the surface of the Earth with a specificity and a permanence that no ground-based installation could match. The Sumerian tablets are explicit about this function. They describe Nanna not merely as a deity of the moon or a being who lives on it, but as one who oversees, who watches, who maintains a gaze upon the Earth that is constant and uninterrupted. And the Apollo astronauts, several of them, came back from the moon with accounts of being watched that their mission psychologists apparently found significant enough to note in records that have only partially entered the public domain. To understand the watching function as the Sumerians described it, we need to spend some time in the text itself rather than in paraphrases of it, because the specific language used is crucial to the argument. The Sumerian deity Nanna is described in multiple tablets using the Sumerian word that translates as the one who gazes, but more specifically in some tablets as the one from whom nothing on earth is hidden. This is not a poetic attribution of omniscience. In its administrative register, it is a description of surveillance capacity. The same root word appears in Sumerian texts that describe the function of human watchtowers, of border posts, of administrative oversight positions. When a Sumerian scribe wrote that Nanna was the one from whom nothing on earth is hidden, he was using the vocabulary of institutional surveillance, not the vocabulary of divine omnipotence. Several of the more detailed Anunnaki texts describe the moon as the station of the far-seeing ones, with a specific emphasis on the far-seeing function as a practical capability rather than a symbolic one. The tablets describe how the Anunnaki used Nanna's station to monitor human populations, to observe the behavior of the humans they had created, and to collect information that was then transmitted to the Great Assembly, the Council of Anunnaki that the tablets describe as governing human affairs from a remove. The moon as information-gathering platform, the moon as the original surveillance satellite, and the people sitting in that satellite watching. Buzz Aldrin has been the most forthcoming of the Apollo 11 crew about what he described as anomalous contacts during the lunar mission. His accounts have varied in detail over the decades and have been subject to considerable editorial compression in their various public presentations, but the core of what he has described is consistent. During the transit to the moon, and while in lunar orbit, the Apollo 11 crew observed objects that they could not identify, that did not match any known hardware associated with their own mission or with any other space program's known activities at that time, and that behaved in ways inconsistent with any known natural phenomenon. The specific accounts have been disputed, recontextualized, and in some cases flatly denied by various parties. But the raw mission communications transcripts, which are part of the public record, contain sections where the crew of Apollo 11 is clearly discussing something they are observing and for which they have no ready explanation. Those sections have received varying degrees of attention from researchers over the decades, and NASA's official response to questions about them has consistently been either that the crew was observing reflections from hardware, or that the conversations are being taken out of context, or that no anomalous events were reported in the official mission logs. The official mission logs are not the complete record of what was communicated during the Apollo missions. They are the edited record. The unedited communications, which exist in various forms of completeness depending on the mission and the time period, contain material that does not appear in the official logs. Some of this material has been published by researchers who obtained it through various means over the decades. Some of it has been discussed by the astronauts themselves in private conversations that were subsequently made public. The category of experience that seems to recur across multiple missions, and that is never addressed in the official public record, is the experience of being observed, of having the clear and unignorable sense that something was watching the astronauts while they were on or near the moon's surface. This is not a category of experience that lends itself to precise data documentation. It is a phenomenological report, the kind of thing that scientists are trained to discount as subjective. But when the same subjective report recurs independently across multiple missions and multiple individuals, the pattern itself becomes a data point. Edgar Mitchell spoke about this more directly than any other Apollo astronaut. In his later years, he described a conversation with members of the intelligence community, people he did not identify by name, who confirmed to him that the encounters reported during the Apollo missions were real, that they were not hardware reflections or psychological artifacts of the extreme stress of lunar spaceflight, and that the decision about how to handle this information publicly had been made at a level above NASA's civilian leadership. Mitchell did not claim to have been told everything. He claimed to have been told enough to understand that the information that came back from the moon included things that the public was never going to be told about, and that this decision had been made deliberately, not out of incompetence or oversight. He died in 2016, and he maintained this account consistently in the years leading up to his death, with increasing specificity and decreasing apparent concern about how it would be received. The Sumerian description of the Watchers and their role connects to this in ways that are difficult to explain away. The tablets describe a function of ongoing surveillance conducted from the moon over human populations that was established at the beginning of what the Sumerians described as the current age of human existence, meaning the period after the Great Flood, that the tablets describe as having nearly destroyed the human species. The Anunnaki decision to maintain a permanent watching station on the moon was, according to the tablets, made at a gathering described as the Great Assembly, which took place after the flood, and which established the parameters of the ongoing relationship between the Anunnaki and human beings. One of those parameters was that humans would be watched, continuously, from the moon. This is not the place to evaluate the theological implications of that description. What it is the place to do is note the structural parallel between what the Sumerians described and what the Apollo astronauts reported. The Sumerians described a watching function built into the moon by its operators. The astronauts reported the experience of being watched while near the moon. These are not the same kind of evidence. One is a 5,000-year-old text in cuneiform. The other is a collection of subjective reports from 12 men who were under extraordinary physical and psychological stress, but they point in the same direction. And when two very different kinds of evidence, separated by 5,000 years and filtered through completely different epistemic frameworks, point in the same direction, the honest response is not to dismiss both of them because neither one alone is conclusive. The honest response is to ask what it would take to explain both of them at once. And to notice that the explanation that explains both of them at once is also the explanation that the people who set the parameters of public scientific inquiry have been most determined to prevent from entering mainstream discourse. The watching function, the surveillance platform, the station of the far-seeing ones, the experience, reported by multiple astronauts across multiple missions, of being observed. The fourth convergence is the one that moves from material anomalies into the realm of purpose. Why would you build a hollow metal shell and park it in perfect mathematical orbit around a planet? What would you use it for? The Sumerians had an answer. The astronauts encountered evidence suggesting the answer was still operational. Whether it still is, in the present moment, as you watch this, and as the moon hangs in its impossibly precise orbit above your head, is a question that the data does not resolve. It only makes more urgent. The fifth convergence concerns the age of the moon, and what the Sumerians said about when it arrived, and why the data from the Apollo missions has consistently produced age measurements that do not fit the story that the moon has been in its current orbit since approximately the same time the Earth itself formed. This is a convergence that requires some patience with geological dating methodology, because the argument depends on understanding why the ages that keep coming back from lunar sample analysis are anomalous, and what the Sumerians said that would explain those anomalies, and why both of those things are being discussed more openly now than at any point since the Apollo samples were first analyzed in the early 1970s. The dominant scientific model holds that the moon formed about 4.5 billion years ago from the debris of the giant impact, which itself occurred shortly after Earth formed about 4.6 billion years ago. Under this model, the moon has been in something like its current orbit for essentially its entire existence, gradually receding from Earth at the current rate of about 3.8 centimeters per year due to tidal energy transfer. If you run this recession rate backwards in time, you arrive at a moon that was 4.5 billion years ago, significantly closer to Earth than it is today, but still in a stable orbit. This model produces a picture of a moon whose age, measured from its formation, should be approximately the same as Earth's age. The problem is that the ages that keep coming back from lunar sample analysis do not consistently produce this picture. Some samples return ages of about 4.5 billion years, consistent with the expected model. But other samples, from different locations and different geological contexts on the lunar surface, return ages that are dramatically different. Some samples return ages significantly older than 4.5 billion years, which is problematic because it is older than the solar system itself, which formed about 4.6 billion years ago, and no solid material should have existed before the solar system formed. These ancient readings have generally been attributed to contamination, to methodological error, or to exotic geological processes that reset the radiometric clocks in ways that produce artificially old readings. All of these explanations are possible. None of them is entirely satisfying given the consistency with which anomalously old readings keep appearing in lunar sample analyses conducted by multiple independent laboratories using different methodologies. There is also the question of the moon rocks that contain ancient crystalline structures. The so-called Genesis rock, collected on Apollo 15, was initially dated to approximately 4.5 billion years and was celebrated as among the oldest material in the solar system. But subsequent analyses of various Apollo samples have produced results suggesting that some lunar highland material may contain structures even older, potentially approaching 4.6 billion years, which would make those structures contemporaneous with or older than the formation of the solar system itself. The specific dates continue to be debated in the technical literature, but the pattern that emerges from the aggregate of lunar age dating is one of extraordinary heterogeneity, wildly different ages, from samples collected in proximity to each other that does not fit the picture of a body with a single formation history. The Sumerian tablets say something about this that is, depending on your tolerance for the implications, either entirely irrelevant mythological noise or one of the most important things written by human hands. The tablets describe the moon as existing before the present world, as an object that was brought to its current position rather than formed in it, as a vessel with a history predating human civilization that was placed in the heavens at a specific time for specific purposes. The Sumerian concept of when this placement occurred is connected to what the tablets describe as the period of the second creation, the re-establishment of human civilization after the Great Flood. The tablets describe the moon's placement in its current orbit as an event that was observed and remembered by early post-flood human populations, not as something that happened in the deep geological past beyond human memory. This is an extraordinary claim. It says that the moon's arrival in its current orbit is within the range of recorded human history, not in the solar system's early period 4.5 billion years ago. If you take this claim seriously, it immediately explains several things. It explains why some lunar samples return anomalously old ages that suggest the material predates the solar system. If the moon is an object from somewhere else, brought here, its constituent materials could be genuinely older than our solar system because they formed somewhere else, around an older star. It explains the heterogeneity of lunar age dates, because a moon assembled from materials from multiple sources over a long operational history would naturally contain material of wildly different ages. And it explains why the moon's current orbital parameters, if reversed at the current recession rate, do not produce the geometrical history that a body in stable orbit for 4.5 billion years should produce, because the moon has not been in its current orbit for 4.5 billion years. Several researchers working in the fields of lunar science and archaeoastronomy have noted independently that ancient human traditions from cultures around the world contain references to a time when there was no moon. These traditions are found in Greek texts, in specific myths attributed to the Arcadians, whom Greek sources described as pre-lunar peoples, in certain ancient Vedic texts, in oral traditions from cultures in Africa and the Americas that were recorded before significant contact with European scholarship. The consistency of these traditions, across cultures with no known contact, describing a period of Earth's human-inhabited history without the moon, has been noted and then typically set aside as unprovable or as misinterpretation of astronomical symbolism. But the Sumerian tradition is not metaphorical or symbolic about the moon's arrival. It is specific. It places the moon's current orbital position as an event within the period of Anunnaki-human interaction, which the tablets themselves date to within the last 100,000 years or so of human existence, not to the deep geological past. The astronaut and space agency conversations that connect to this fifth convergence are more indirect than the previous ones, because the question of when the moon arrived in its current orbit is not something that astronauts observe directly on the surface. What connects to this convergence from the mission record is the anomalous age data itself, and the specific institutional decisions about how to handle it. Scientists who worked on the Apollo sample analyses in the 1970s have described, in various interviews and memoirs over the decades, the atmosphere of controlled confusion that surrounded the age data as it came in. The readings were not what anyone expected. Some samples were behaving as expected. Others were producing results that, in the words of one scientist who worked on the analysis, we did not know what to do with. Not because the methodology was failing, because the results did not fit any model of lunar history that anyone was willing to publicly propose. What do you do when your data does not fit your model? In civilian science, you revise the model. In institutionally embedded science, particularly in the context of a space program that was operating under extraordinary political pressure and public scrutiny during the Cold War, you face a choice. You can revise the model and deal with the consequences of explaining to the public why the moon is not what you said it was. Or you can defer the revision, categorize the anomalous data as requiring further study, and allow the mainstream model to persist while the anomalies accumulate in the technical literature where most people will never read them. The second choice is not a conspiracy. It is the path of least institutional resistance, and it has been followed with impressive consistency across every space agency and every decade of post-Apollo lunar research. The Sumerians did not have institutional resistance to contend with. They wrote what they were told. What they were told was that the moon was brought here, that it had a prior history that predated its placement in Earth's orbit, and that this placement was intentional, executed by the Anunnaki for purposes that included the establishment of the timekeeping system and the surveillance function we have already discussed. The fifth convergence is the one that reaches the furthest back in time, and it is the one that, if correct, has the most profound implications for every other aspect of lunar science. If the moon was brought here from somewhere else, by someone, then all the anomalies collapse into a single coherent explanation. The hollow interior, the anomalous surface materials, the impossible mathematical precision of the orbital parameters, the ancient age of certain samples, the heterogeneity of the age data. All of these become the expected characteristics of a constructed vessel, with a long operational history, placed in its current position relatively recently in geological terms, by entities that the oldest written records in human history knew by name. The sixth convergence is the one that the scientific community finds most difficult to engage with, because it involves a characteristic of the moon that is objectively measurable, that has been measured repeatedly by multiple independent sources, and that produces a result so geometrically specific that the word coincidence does not even function as a temporary placeholder explanation the way it does for the other anomalies. The sixth convergence is about the moon's role as a gravitational stabilizer for Earth's axial tilt, and about the Sumerian description of this function as a deliberate engineering decision. The science here is not disputed. The engineering interpretation is. And the Sumerian record, as with the other six convergences, does not leave room for the interpretation that this function was discovered after the fact. It describes it as a design specification. Earth's axial tilt, the angle at which our planet is tilted relative to its orbital plane around the Sun, is approximately 23.4 degrees. This tilt is what produces the seasons, the variation in day length throughout the year, the differential solar heating that drives weather patterns and ocean circulation. Without axial tilt, Earth would have no seasons. The equator would be a permanent heat band, the poles would be permanent ice sheets, and the temperate zones that support most complex terrestrial life, including all of human civilization, would not exist in anything like their current form. The specific value of 23.4 degrees is not the only possible axial tilt that could support complex life, but it is within a range that produces the particular conditions that allowed the specific kind of complex life that evolved on Earth to evolve in the specific way that it did. More on why the specific value matters in a moment. Mars has no moon of comparable size relative to its own mass. Mars has two tiny moons, Phobos and Deimos, that are effectively captured asteroids and have essentially no gravitational influence on Mars's orientation in space. As a result, Mars's axial tilt is not stable. Computer models of Mars's rotational history show that its axial tilt has varied chaotically between 0 and about 60 degrees over geological timescales, sometimes tilted almost on its side, sometimes nearly upright. This chaotic variation in axial tilt is considered by planetary scientists to be one of the factors that makes Mars inhospitable to the development of complex, stable biospheres. Earth's axial tilt does not behave this way. It varies, but only slightly and very slowly, between about 22.1 and 24.5 degrees over a cycle of about 41,000 years. This slow, bounded variation is called the obliquity cycle, and it contributes to the long-term climate cycles that have influenced the timing of ice ages. But it is bounded variation, not chaotic variation. Earth's axial tilt does not wander randomly through a wide range. It is locked into a narrow corridor of relatively stable values, and it has been maintained in this corridor for at least the last several 100 million years, long enough for complex animal life to evolve and for the biosphere to develop the stability that makes long-term evolutionary progress possible. The moon is the reason for this stability. Specifically, it is the moon's gravitational influence on Earth's equatorial bulge, the slight flattening at the poles and bulging at the equator that results from Earth's rotation that provides the stabilizing torque that prevents Earth's axial tilt from wandering chaotically the way Mars's does. Computer simulations that remove the Moon from the Earth-Moon system and then model Earth's subsequent rotational evolution consistently produce chaotic axial variation, Mars-like in its amplitude and unpredictability. Simulations that include a Moon of the Moon's size and mass in the Moon's orbit produce the stable, slowly varying obliquity cycle that Earth actually has. The Moon is a stabilizing mechanism for Earth's climate. It is maintaining the conditions under which complex life can exist on the surface of this planet, and it is doing so with the particular efficiency that comes from being exactly the right size, at exactly the right distance, in exactly the right orbital inclination, to perform this specific function. Now here is what makes this extraordinary. Beyond the coincidence of sizes and distances that we examined in the second convergence, the Moon's stabilizing effect is not a happy accident of its formation. It is the result of very specific values of mass, distance, and orbital inclination that, if any of them were significantly different, would substantially reduce or eliminate the stabilizing function. The Moon would need to be much smaller or much farther away to fail to stabilize Earth's axial tilt, but it would need to be much closer or much larger to destabilize it through tidal forces that would accelerate Earth's rotation to the point of disrupting the very climate stability it currently maintains. The Moon sits in what researchers have described as the Goldilocks zone of stabilizing influence, providing exactly the right amount of gravitational coupling to maintain axial stability without disrupting the other planetary parameters that make Earth habitable. This is not one coincidence. This is a stack of coincidences, each one building on the others, that together describe a system that has been tuned. The Sumerian tablets describe the placement of Nanna in its current position as having among its stated purposes the holding of the Earth in its proper balance. The specific Sumerian language uses a term that appears elsewhere in texts describing the balancing of physical scales, of weighted measurement instruments, of the kind of precisely calibrated balance that Sumerian craftsmen used for weights and measures. The tablets describe Nanna as performing a holding function, a stabilizing function, not merely as a passive object in the sky, but as an active participant in the maintenance of the Earth's orientation in space. This is not the only interpretation of those passages. Mainstream Assyriology interprets the holding and balancing language as mythological description of the Moon's role in seasonal cycles and its relationship to the agricultural calendar. But the specific vocabulary, yet again, is not the vocabulary of mythology. It is the vocabulary of engineering and measurement. The texts that are most specific about this function are associated with the Anunnaki figure called Enlil, the Lord of the Air, whose domain included Earth's atmosphere and climate. The tablets describe Enlil as having specified the parameters of Nanna's placement in a way that would ensure the maintenance of proper conditions on Earth's surface. The holding function, the balancing function, was part of the specification that Enlil provided when the assembly of the Anunnaki decided to place Nanna in its current orbit. This is described not as divine magic or supernatural intervention, but as an engineering decision made with specific outcomes in mind. The outcome specified was the stability of Earth's surface conditions. The mechanism by which that stability would be achieved was the gravitational influence of Nanna on Earth's axial orientation. And the result of that decision, if the Sumerian record is to be believed, is the temperate, seasonally stable, life-supporting climate that has characterized Earth's surface for the period of Anunnaki-human interaction, and that continues to this day. The conversations among Apollo mission scientists that connect to this sixth convergence are not about axial stability directly. They are about the broader question of the Moon's function, about whether the object the Apollo missions characterized was a naturally occurring planetary body that happened to perform this stabilizing function, or whether the stabilizing function was itself evidence of intentionality. This is a question that did not have an official home in the Apollo scientific program. The program was designed to characterize the lunar environment, to collect samples, to test models of lunar formation and evolution. It was not designed to ask whether the Moon had a purpose, but the scientists who looked at the aggregate of anomalous findings from the Apollo missions, some of them, did ask that question. In the technical literature, the question gets translated into the safe language of unlikely coincidences, of improbable parameter combinations. No further study required. In private conversations, some of which have entered the record through memoirs and interviews and oral history projects, it was asked more directly. The holding of the Earth in its proper balance. That is what the Sumerians said Nanna was placed in the sky to do. That is precisely, In the language of modern planetary science, what the moon is doing. The sixth convergence is the one where the functional description in the ancient text matches the scientifically documented function most completely and most uncomfortably. Every word of the Sumerian description is confirmed by modern planetary science. The only part that modern planetary science refuses to confirm is the part that says it was done on purpose. The seventh convergence is the one that synthesizes everything that came before it, and it is the one that the Sumerian texts treat not as a revelation but as a matter of established record. The seventh convergence is about the far side of the moon, what is on it, what the Sumerians said was on it, and what every space agency with the capability to examine it has found there, and what has been decided across multiple independent institutional structures in multiple countries, with no formal agreement between them, not to discuss in public scientific channels. The convergence here is not just between the Sumerian record and the data. It is between the Sumerian record, the data, and a pattern of institutional behavior that has been consistent enough and consistent across enough independent institutions that explaining it as coincidence requires a degree of credulity that the data itself does not support. We will begin with what we actually know about the far side of the moon from publicly available information, because there is more of it than most people realize, and some of it is genuinely extraordinary. The far side of the moon was first photographed by the Soviet Luna 3 probe in 1959, and the images that came back produced significant surprise among the scientists who analyzed them. The far side does not look like the near side. It is geologically different in ways that the existing models of lunar formation and evolution do not satisfactorily explain. The near side of the moon is covered with large, dark plains called maria, the Latin word for seas, which are ancient lava flows that flooded low-lying basins after large impact events. The far side has almost no maria. It is almost entirely covered with ancient highland terrain, heavily cratered, without the volcanic flooding that characterizes the near side. This asymmetry is called the near-far dichotomy, and it is one of the most prominent and least explained features of the moon's geology. Several hypotheses have been proposed to account for it. One hypothesis involves a second, smaller moon that collided with the far side in the early history of the Moon-Earth system, covering it with ancient highland material. Another involves thermal differences in the early lunar magma ocean that produced different solidification patterns on the two hemispheres. None of these hypotheses is fully satisfying to lunar scientists, and the near-far dichotomy remains, in the technical literature, an active research problem rather than a solved one. What the near-far dichotomy does, regardless of how it is ultimately explained, is create a situation where the hemisphere of the moon that permanently faces Earth is dramatically different from the hemisphere that permanently faces away from it. This difference was not known to exist before space exploration. It was not predictable from Earth-based observations. And it raises a question that the Sumerian record addresses directly. Was the near-far difference a designed feature or an accident of formation? The Chinese space program has conducted the most extensive exploration of the far side of the moon of any national space agency in history. The Chang'e 4 mission, which landed in the von Karman crater on the lunar far side in January 2019, marked the first soft landing on the far side in history. The Chang'e 4 rover, called Yutu-2, has been exploring the far side since then and has produced a significant body of data. Some of that data has been published in mainstream scientific journals and has attracted considerable attention. Some of it has been the subject of press releases and official statements. But there is a category of Chang'e 4 data that has been noted by researchers who follow Chinese space science closely as conspicuously absent from the official publications, data relating to certain subsurface anomalies detected by the rover's ground-penetrating radar, anomalies that have been described in some accounts, though not in official Chinese space agency publications, as inconsistent with natural geological layering. The Indian Chandrayaan-1 mission, which orbited the moon in 2008 and 2009, carried instruments that were designed to detect water ice in permanently shadowed craters near the lunar poles. It found evidence of water molecules, which was a significant result that was published and celebrated. What received less attention in the public scientific press were certain anomalous reflectance readings from the moon's far side that the Chandrayaan-1 science team reported internally but did not include in their initial, published findings. These anomalies were described in a subsequent paper in technical language as requiring further investigation, a phrase that in lunar science has come to function almost as a technical term, meaning we do not know what this is and we are not sure what to do with it. The Japanese Kaguya mission, also known as SELEN, orbited the moon between 2007 and 2009 and produced what is still one of the most comprehensive datasets in lunar orbital science. The Kaguya team published an extraordinary amount of data and made much of it publicly available, which was itself notable given the institutional pressures that tend to restrict access to anomalous findings. The Kaguya gravity data revealed something that planetary scientists have been quietly working with ever since. The moon's mass distribution is not what a naturally formed body would be expected to have. The mass is concentrated in specific regions, called mascons, short for mass concentrations, that produce gravitational anomalies detectable from orbit. Mascons were first identified from Apollo-era orbital tracking data, but Kaguya's gravity mapping refined the picture considerably. The mascon distribution is not random. It is not consistent with the distribution expected from a history of large impact events, which should produce somewhat chaotic mascon patterns. The Kaguya mascon data shows a distribution that some researchers have described, though cautiously and with significant hedging, as more regular than expected. Regular is a word that carries a great deal of weight in that context. A regular distribution of mass anomalies in a natural planetary body is an extraordinary finding. A regular distribution of mass anomalies in a body that the seismic data suggests is hollow or semi-hollow, in a body that contains anomalous concentrations of titanium and other processed-looking materials, in a body whose orbital parameters are precisely calibrated to perform specific functions relative to Earth, in a body whose far side is geologically anomalous in ways that existing models cannot satisfactorily explain, that kind of regularity begins to describe something specific. It begins to describe an internal structure, a designed one. The Sumerian tablets describe the far side of Nanna's vessel as the place of concealment, as the face that does not look upon the earth, as the location of what the tablets call the inner chambers of the great construction. The Anunnaki texts describe the far side of the moon as the working side, the operational side, as distinct from the near side, which faces Earth, and which the tablets describe as having been designed to present a specific appearance to the inhabitants of Earth below. The word translated as designed appears in that context in its manufacturing and intentional action verbal form. The near side of the moon looks the way it looks because it was made to look that way. The far side is where the operational infrastructure of Nanna's vessel is located. This is, on the face of it, an extraordinary claim to find in a 5,000-year-old clay tablet. But consider what we actually know about the near-far dichotomy from modern science. The near side is smooth, relatively, with large dark planes that create the face-like pattern that humans across cultures have interpreted as a face for as long as recorded human history extends. The far side is rough, ancient, heavily cratered, without the smoothing volcanic floods that characterize the near side. If you were constructing a vessel whose near side was meant to look natural and unthreatening to inhabitants of the planet it orbited, and whose far side was where the actual operational infrastructure was located, the near-far dichotomy is exactly what you would expect to see. The volcanic plains on the near side provide a natural-looking surface that, from a distance, does not immediately suggest artificial construction. The ancient highland terrain of the far side conceals whatever is actually there beneath 4 billion years of micrometeorite impact gardening and geological dust. The astronauts who flew around the moon, and therefore saw the far side from close range, from lunar orbit, have been even more circumspect about the far side than about the near side. The far side of the moon is where radio communications with Earth are blocked. There is a window of several minutes in each orbit, for a spacecraft in low lunar orbit, during which the far side passes between the spacecraft and Earth, and during which the spacecraft cannot communicate with mission control. This window has been described in various contexts as a privacy window, as a period of radio silence, as a technical consequence of lunar orbital mechanics. It is all of those things. It is also the period during which anything an astronaut observed on the far side would be observed without being transmitted in real time to Earth. The gap in the communications record for this window is structural, not selective. No one had to make a decision to not record what was seen during the far side pass. The communications simply did not exist. What astronauts said about what they saw during those passes, in debrief conversations after returning to Earth, is a different matter. What has been made public of those debriefs is not the complete record. This is not a contested claim. It is a straightforward consequence of the classification structure that surrounds astronaut debriefs, some of which remain partially restricted decades after the missions. The seventh convergence is the most complete and the most disturbing, because it encompasses not just the specific Sumerian claims about the far side of the moon, but the aggregate of everything else we have examined and the institutional response to that aggregate. The Sumerians described the far side as the place of concealment, as the operational side of Nanna's vessel, as the location of the inner workings of a structure that was placed in its current orbit by entities with purposes that included the stabilization of Earth's climate, the surveillance of Earth's population, and the provision of a timekeeping system for the human civilization those entities had established and maintained. Every one of those functions corresponds to something that modern science has confirmed, in its own language and within its own frameworks, without acknowledging the correspondence. The hollow interior corresponds to the seismic data. The stabilizing function corresponds to the axial tilt mechanics. The surveillance function corresponds to the astronaut reports of being observed. The timekeeping function corresponds to the extraordinarily precise orbital parameters. The anomalous surface materials correspond to the geological findings from Apollo and subsequent missions. The ancient origins of the constituent material corresponds to the anomalous age data. And the operational far side corresponds to the near-far dichotomy that has never been satisfactorily explained by any natural formation model. 7 convergences. 7 points where the oldest written records in human history and the most recent scientific data point to the same conclusion. A conclusion that the institutions of modern science have been structurally unable to engage with, because engaging with it honestly would require dismantling assumptions about the nature of the moon, the history of the solar system, the origin of human civilization, and the relationship between human beings and whatever made the object that hangs in our sky every night, that we have looked at since before we could write, that we have navigated by and planted crops by and been awed by, and that the Sumerians told us, in careful administrative prose written in the witness record register, was put there by someone for a reason, and that the reason was us. We need to return now to the first convergence and go deeper into it, because the seismic data from the Apollo missions is the foundation upon which everything else in this investigation rests, and it deserves considerably more examination than the summary we gave it at the outset. The ringing of the moon like a bell is not a metaphor that researchers arrived at casually. It is the literal description of what the seismometers recorded, and the technical implications of that description have been unfolding in the scientific literature ever since the data was first analyzed. To understand why the seismic data is so anomalous, you need to understand what seismic data from a solid rocky body is supposed to look like. When an impact or seismic event occurs on a solid, geologically inactive body, like an asteroid or a rocky moon, with no internal fluid layers, the seismic waves propagate through the body and dissipate relatively quickly. The body absorbs the energy. You get a sharp signal that decays rapidly, typically within seconds to minutes for small events. This is what planetary seismologists expected to record on the moon. The moon has no liquid core, as far as any of the indirect evidence suggests. It has no liquid outer core like Earth's, which would provide a layer through which shear waves could not propagate and which would create a characteristic seismic signature. It has no liquid water. It should have behaved seismically like a dead rock. Instead, it behaved like a structure that is specifically designed to propagate and sustain seismic energy over extended periods. The decay time of the ringing from the November 1969 Apollo 12 lunar module impact was measured at approximately 55 minutes. The decay time from the much larger Saturn V third stage impact in April 1970 was measured at approximately 3 hours and 20 minutes. For reference, a major earthquake on Earth, occurring in the planet's rocky upper crust, produces seismic waves that decay to background noise levels within minutes. The Moon's seismic response to the 1970 impact was sustained for 200 minutes. This is not a slightly unusual result. It is a qualitatively different category of physical behavior. The Moon is doing something that solid rocky bodies do not do. The scientific literature on this anomaly is extensive and technically detailed. The key paper is usually cited as the Nakamura et al. 1973 paper on seismic observations of the Moon, but there is a substantial body of follow-on work that has refined and extended the original findings. What has emerged from this literature over the decades is a picture of a moon that has what seismologists call an anomalously low seismic attenuation coefficient. Attenuation, in seismology, refers to the rate at which seismic energy is absorbed by the medium through which it travels. Rock absorbs seismic energy well. Metal absorbs it less well. Hollow structures absorb it least of all because the seismic energy cannot dissipate into a void and instead continues to propagate along the walls of the structure. The Moon's attenuation coefficient is, in the words of the technical papers that document it, unlike any other known planetary body, by which the authors mean that it is lower than any naturally occurring solid body we have ever seismically characterized. There have been attempts to explain this low attenuation without invoking a hollow or structured interior. One hypothesis involves the extreme dryness of the lunar interior. On Earth, groundwater in rock acts as a seismic damper, helping to absorb energy. The Moon has no groundwater, and the hypothesis is that the extreme dryness of the lunar crust allows seismic energy to propagate farther and decay more slowly than it would in wetter rock. This explanation has some merit as a partial factor. Dry rock does have lower attenuation than wet rock, but the quantitative difference between dry rock on Earth and the Moon's seismic behavior is so large that dryness alone cannot account for it. The lunar attenuation values are not slightly lower than dry rock. They are dramatically lower, in ranges that approach the behavior of metallic structures rather than rocky ones. The Vassin and Sherbakov paper from 1970, which we mentioned in the opening section of this presentation, went considerably further in its technical analysis than is usually acknowledged in secondary sources. The paper did not merely propose a hollow moon as a fanciful speculation. It worked through the engineering parameters that would be required to produce the observed seismic behavior, and concluded that the outer shell of the moon, if it is a hollow or semi-hollow structure, would need to be composed of material with mechanical properties significantly exceeding those of natural rock. The paper estimated the shell thickness, based on the seismic data, at somewhere between 15 and 35 kilometers, and noted that the material properties implied by the seismic behavior are more consistent with a processed metallic alloy than with silicate rock. Processed metallic alloy is another way of saying manufactured material. Titanium alloy is one candidate. And titanium, as we discussed in the third convergence, is present in the lunar surface in concentrations that have no natural explanation. The Sumerian tablets describe the bones of Nanna's vessel, the structural elements of the moon's interior, using terms that include the word for enduring metal, a word that appears elsewhere in Sumerian metallurgical texts describing alloys that have been specifically processed to resist deformation and damage. The tablets also describe the thickness of Nanna's outer shell, using a measurement system that is difficult to translate into modern units with precision, but which scholars of Sumerian metrology, the study of ancient measurement systems, have estimated corresponds to a range of roughly 10 to 40 kilometers, depending on which interpretation of the relevant Sumerian unit of length is used. This range overlaps with the Vassin-Sherbakov estimate of 15 to 35 kilometers. The overlap may be coincidental, but it is there, and it invites the question of how a Sumerian scribe, working in the 3rd millennium before the Common Era, arrived at a description of the moon's structural shell thickness that falls within the same order of magnitude as the estimate derived by 20th century seismologists, analyzing mission data from 6 Apollo landings. No one at NASA or any other space agency has publicly proposed a hollow moon or a structured moon as a serious scientific hypothesis in the decades since the Apollo data was collected. The institutional barriers to making such a proposal are formidable. The hypothesis would require rejecting the giant impact model of lunar formation, which is supported by a great deal of other evidence beyond the seismic data, and replacing it with something that has no precedent in planetary science. It would require proposing that an artificial object of moon scale exists in our solar system, which has implications so vast that the scientific community simply does not have a framework for dealing with them. It is much easier, institutionally, to continue attributing the anomalous seismic behavior to exotic natural processes, and to continue requiring further study rather than reaching the conclusion that the data, read without pre-commitment to naturalistic explanation, actually supports. The Sumerians did not have this institutional problem. They wrote what they were told, and what they were told was that Nanna's vessel rang, that it resonated, that its inner chambers carried sound and vibration in ways that lesser materials could not, and that this was a property of the material from which the vessel was constructed, a material that they described as enduring and processed and unlike the rock of the earth. They did not arrive at this description through seismology. They arrived at it through information provided by the Anunnaki, who, if the tablets are to be taken at face value, built the thing. And they wrote it down in the witnessed record register, in the careful administrative prose that the most literate civilization in early human history used for the facts they did not want to lose. We should also spend more time with the question of the Anunnaki themselves, because no examination of the Sumerian lunar record is complete without grappling with who the Sumerians said gave them this information, and with what the scholarly record actually says about the reliability and internal consistency of those accounts. This is not a detour from our main argument. It is the backbone of it. The 7 convergences we have examined are not interesting because the Sumerians were gifted astronomers who figured these things out by careful observation. They are interesting because the Sumerians explicitly and repeatedly said that they did not figure these things out. They said they were told. And they named who told them. The Anunnaki appear in Sumerian literature with a consistency and specificity that distinguishes them sharply from the vague supernatural forces that populate the mythological traditions of most other ancient cultures. The Greek gods are allegories wearing human faces. The Hindu devas are cosmic principles given narrative form. The Norse Aesir are nature forces elevated to personhood. The Anunnaki are administrators. They have ranks, they have titles, they have specific areas of responsibility. They have disputes with each other that are resolved through council decisions. They have policies for dealing with human populations that change over time in response to circumstances. They behave, in the Sumerian texts, less like supernatural beings and more like a competent, hierarchically organized institution with a clear chain of command, an established legal framework, and a long institutional memory. The scholar Zecharia Sitchin, whose translations of Sumerian texts produced the most detailed and most controversial reading of the Anunnaki materials in the 20th century, is often dismissed in academic circles on the grounds that his translations are not philologically rigorous, that he imposes his own interpretive framework on ambiguous cuneiform signs, and that his conclusions about the Anunnaki as extraterrestrial beings who visited Earth and shaped human civilization are not supported by mainstream Assyriology. These criticisms have merit, and they should be acknowledged honestly. Sitchin's translations are not peer-reviewed scholarship in the technical sense. His philological decisions are sometimes disputed by specialists. His interpretive framework is speculative in ways that go well beyond what the evidence compels. But the dismissal of Sitchin should not be allowed to accomplish what it is often used to accomplish, which is the dismissal of the underlying Sumerian texts themselves. The texts exist independent of Sitchin's translations. They have been translated by multiple mainstream scholars working in academic institutions with no apparent connection to alternative history research. Samuel Noah Kramer, who was one of the 20th century's most respected Sumerologists and who held a chair at the University of Pennsylvania, translated extensive portions of the Sumerian literature and expressed, in various publications, a sense of astonishment at the sophistication and specificity of the material he was working with. He did not conclude that the Anunnaki were extraterrestrials. He concluded that the Sumerians had access to knowledge about astronomy, geology, and biology that was far beyond what their technological level should have allowed. He attributed this to a precociously gifted civilization. The alternative attribution, the one that the Sumerians themselves would have offered, is the one that Sitchin followed to its logical conclusion. The question of whether the Sumerian description of the Anunnaki is a projection or a report is ultimately unanswerable using the available evidence. But the question of whether the Sumerian descriptions of the moon contain accurate information about the moon's physical characteristics is not unanswerable. We have tested those descriptions against the data. We have found convergences. 7 of them, each one specific, each one verifiable from the scientific literature, each one describing a characteristic of the moon that the Sumerians had no known technological means of discovering independently. The convergences do not prove that the Anunnaki told the Sumerians these things. They prove that the Sumerians somehow knew these things. And the explanation for how they knew them that the Sumerians themselves provided was, the Anunnaki told us. The Anunnaki texts contain a passage, in the Atrahasis narrative, where the senior Anunnaki figure Enki describes to the human scribe Atrahasis, a principle that translates roughly as the proper ordering of knowledge, a principle by which certain categories of information should be made available to human beings, and certain other categories should be withheld. The categories that should be made available are, according to the text, those relating to agriculture, to law, to the organization of society, and to the observation of the heavens for the purpose of timekeeping and navigation. The categories that should be withheld are those relating to what the tablets call the deeper nature of the heavens, meaning the inner workings of the cosmos beyond what is visible from Earth's surface. The moon's physical characteristics fall, in this taxonomy, into the category of what should be made available, because the moon is part of the visible heavens used for timekeeping and navigation. Its specific structural properties, its hollow interior, its metallic shell, its placed rather than formed origin, these fall closer to the category of deeper nature of the heavens. And yet the Sumerian tablets contain both categories, the timekeeping information and the structural information. Either Enki's policy of selective disclosure was not perfectly enforced, or the scribes who wrote in the witnessed record register, had access to sources of information that transcended the official policy of what should be told to humans. Either explanation is interesting. The first suggests that information that was supposed to be withheld got through anyway, through channels that the Anunnaki institutional structure could not fully control. The second suggests that the witnessed record scribes occupied a privileged position in the information flow, perhaps as intermediaries between the Anunnaki and the broader human population, and that their access was intentionally broader than what was provided to the general population. Both of these explanations are consistent with the structure of the texts as we have them. The witnessed record sections consistently contain more technical and more specific information than the narrative sections. This is not a feature that would result from scribes making up technical details to embellish good stories. It is a feature that would result from scribes recording technical information provided to them by sources that had it. The question of who those sources were is the question that the seventh convergence, the convergence of the far side and the operational infrastructure, raises most directly. If the moon is a constructed object placed in Earth's orbit by entities who were interacting with early human civilization, then those entities were, at some point, present on Earth, or at least in communication with people on Earth, providing information that eventually made its way into the Sumerian written record. The Sumerian texts say this explicitly. The Anunnaki interacted with human populations. They established cities. They provided knowledge. They created administrative structures through which that knowledge was preserved and transmitted, and they eventually departed, or reduced their visible presence, or changed the nature of their interaction with humanity, in ways that the texts describe but do not fully explain. What remains is the moon, still in its precise orbit, still performing its stabilizing function, still presenting the same smooth face to Earth while its operational far side faces the void, still ringing when struck, after all these years, like something that was made rather than formed. The question of the moon's water, and what the Sumerians said about water in relation to Nanna's domain, opens another dimension of the seven convergences that deserves its own extended examination. Water on the moon was, for the first several decades of post-Apollo lunar science, considered to be essentially absent. The Apollo samples showed a lunar surface of extraordinary dryness. The silicate minerals in the samples contained far less bound water than comparable Earth rocks. The hypothesis was that any water that might have been present when the moon formed had been driven off by the heat of the giant impact event and by the subsequent billion years of solar wind bombardment on a body with no magnetic field and no atmosphere to protect it. This hypothesis was not definitively wrong. The lunar surface in most locations is indeed extraordinarily dry, but it was not the complete picture. Beginning in the 1990s and accelerating dramatically through the 2000s and 2010s, a series of orbital and impact missions produced evidence that the moon contains water ice in permanently shadowed craters near both poles, where the geometry of the crater walls prevents sunlight from ever reaching the crater floor, and where temperatures can fall below -200 degrees Celsius, cold enough to trap and preserve volatile compounds, including water, for billions of years. The evidence for lunar polar water ice accumulated from multiple independent sources. The Clementine mission in 1994 produced radar reflectance data that was consistent with the presence of water ice. The Lunar Prospector mission in 1998 detected elevated concentrations of hydrogen near the poles, consistent with water ice. The Elsie Ross mission in 2009 deliberately impacted a rocket stage into the Cabeus crater near the lunar South Pole and detected spectroscopic signatures of water vapor and ice in the resulting debris plume. The India Chandrayaan, one mission's moon mineralogy mapper instrument, detected surface water molecules at latitudes well away from the poles, suggesting that water migration and temporary surface absorption of water from solar wind hydrogen may be more widespread than the polar ice deposits alone. Taken together, this body of evidence describes a moon that contains significant quantities of water, concentrated primarily in polar permanently shadowed regions but present at trace levels across much of the surface. The total quantity of water ice in the lunar polar deposits has been estimated at potentially billions of tons, though the estimates vary considerably depending on the instrument and the methodology. This is not a small amount. It is a resource that has been identified as one of the key enablers of long-term human presence on the moon, because water can be electrolyzed into hydrogen and oxygen for rocket fuel, and because it can, of course, be used directly to support life. The Sumerian texts describe Nanna's domain in relation to the cosmic waters in ways that are interesting for reasons that go beyond the discovery of polar ice. The tablets use a specific Sumerian concept, the Abzu, to describe the repository of primordial water that the Anunnaki god Enki was associated with, and that was described as existing in the depths beneath the surface of various important locations, including the depths of the heavens. The Abzu is typically translated as the primordial underground water table or the cosmic deep, and it is interpreted in mainstream Assyriology as a mythological concept analogous to similar primordial water traditions in other ancient cultures. But the specific Sumerian language describing Enki's relationship to the Abzu beneath Nanna's domain, which appears in certain texts connecting Enki's role as the keeper of cosmic knowledge with the moon's operational nature, uses terms that describe the Abzu as a physical substance stored and maintained, not as a mythological entity. In the context of the Anunnaki's management of the moon as a vessel and as an operational platform, the presence of vast quantities of water in permanently shadowed regions takes on a significance that the mythological interpretation misses. Water is fundamental to long-term habitation. It is fundamental to biological life. It is fundamental to the kind of industrial processes that the tablets describe the Anunnaki as conducting. If the moon was placed in its current orbit as an operational base, as a platform for surveillance and for whatever other purposes the tablets enumerate, then the presence of large quantities of stored water in protected locations on that moon is not a coincidental geological feature. It is exactly what you would expect to find if someone stocked the vessel before deploying it. The astronaut discussions of lunar water have been consistent with the broader pattern of partial disclosure that characterizes the treatment of lunar anomalies. The discovery of lunar polar ice was not treated as a bombshell revelation when it was confirmed in 2009, partly because the evidence had been accumulating for over a decade, and partly because the mainstream interpretation of lunar ice as a straightforward geological consequence of comet and asteroid impacts in polar regions provides a natural explanation that requires no unusual hypotheses. Comets and asteroids carry water. They impact the moon. Some of the water migrates to cold traps at the poles. This is a plausible account that most planetary scientists accept. It does not require invoking Anunnaki water storage. But the plausibility of the natural explanation should not be allowed to foreclose examination of the pattern that the water evidence adds to the overall picture. A hollow moon with a metallic shell containing anomalously processed surface materials in a precisely calibrated orbit performing specific stabilizing and surveillance functions that also has significant water deposits in protected polar locations describes something that could, with all its individual anomalies explained away naturalistically one at a time, be accepted as a very unusual but ultimately natural body, or it describes something else. The natural explanations for each individual anomaly are individually plausible. The question is whether the aggregate of individually plausible natural explanations for a list of anomalies this long and this specific is itself a plausible description. At some point, the accumulation of unusual coincidences that each require their own natural explanation begins to require a prior probability assessment. How probable is it that all of these things are true simultaneously about a naturally formed body? The mathematicians who have looked at this question have not arrived at comforting answers. The Sumerian connection to lunar water is not, by itself, one of the 7 convergences we have identified. But it supports the structural argument of the 7th convergence, the far side and operational infrastructure convergence, in a way that adds specificity to the overall picture. An operational base needs water. The moon has water, in quantities sufficient to sustain long-term operations, stored in locations that are permanently cold and therefore permanently stable. The Sumerians described Enki's cosmic water as present in Nanna's domain. The science confirms the water. The purpose of the water in the Sumerian description is operational. The purpose in the natural explanation is geological. The difference between those two purposes is the difference between a habitat that was stocked and a geological accident that happens to be useful. The Sumerians were clear about which one it was. We need to address directly the institutional silence that surrounds this body of evidence, because it is itself a significant piece of the puzzle, and it has a history that can be traced with more specificity than the broad claim of cover-up that characterizes most alternative history discourse. The institutional response to lunar anomalies has not been a single coordinated decision made in a smoke-filled room. It has been a series of individually rational decisions made by individual scientists and administrators in specific institutional contexts, each of which made sense from within its own framework, but which, in aggregate, has produced something that functions exactly like a coordinated cover-up, even if it was never designed as one. Understanding how this happens is important, because it explains why the silence on lunar anomalies is not evidence that the anomalies are trivial. It may actually be evidence that they are not. The key dynamic is what institutional sociologists call the spiral of silence, a mechanism by which a minority position, in an institutional context, tends to suppress itself through anticipation of social costs rather than through direct coercion. A scientist who analyzes the seismic data from the Apollo missions and arrives at the conclusion that the most parsimonious explanation for the data is a hollow or structured moon does not need to be told by anyone in authority to keep that conclusion to themselves. They know, from the institutional context they operate in, that publishing such a conclusion would require them to propose the abandonment of the giant impact model, the rejection of standard planetary formation theory, and the adoption of a hypothesis, artificial moon, that has no precedent in any recognized scientific framework. The career consequences of publishing such a paper without extraordinary and conclusive evidence would be severe. The individual scientists most likely to arrive at this conclusion are also the scientists with the most to lose by publishing it, because they are the most senior and most credentialed members of the field. So they file their anomalous findings under further study required, and they move on to the next task, and the anomaly persists in the technical literature without ever reaching the threshold of public attention. This dynamic has been described, not in relation to lunar science specifically, but as a general mechanism by several sociologists of science. The specific application to anomalous planetary science data was made explicit by Dr. John Brandenburg, a plasma physicist who worked on several NASA projects and who published work on Martian anomalies that drew significant attention both inside and outside mainstream science. Brandenburg described, in interviews and in written work, the atmosphere of what he called institutional caution that surrounded anomalous findings in planetary science, a caution that was not enforced by explicit prohibition but by the shared understanding among scientists of what kinds of findings were career-enhancing and what kinds were career-terminating. Anomalous findings that could be accommodated within the existing framework were career-enhancing. Anomalous findings that required dismantling the existing framework were career-terminating. Lunar seismic anomalies fall squarely in the second category. The Sumerian record, of course, is completely insulated from all of this. The tablets in the museums of Baghdad, London, Berlin, and Philadelphia do not change their content based on what NASA publishes. The scribes who wrote them are 5,000 years beyond the reach of peer review committees and institutional funding structures. The information they recorded, whatever its source and whatever its original purpose, is simply there, in the clay, in the cuneiform, available for reading by anyone who knows the language and has access to the published translations. The 7 convergences we have documented in this presentation are not the product of wishful reading or motivated reasoning. They are the result of comparing specific, technically worded descriptions in the Sumerian witnessed record texts with specific, technically documented findings in the modern scientific literature on the moon and noting where the two bodies of information describe the same things. The noted convergences are real. The question of what they mean is the question that each person who encounters them must answer for themselves. There is one more category of Sumerian lunar information that we have not yet addressed, and it is perhaps the most personally significant of all the convergences we have examined, because it concerns not the physical properties of the moon, but its relationship to human consciousness and to the biological functions of the human beings who live beneath it. The Sumerian texts describe Nanna's influence on human beings in ways that go considerably beyond the control of agricultural cycles through the lunar calendar. The tablets describe specific neurological and psychological influences of the moon on human perception, memory, and what the Sumerians called the inner life, a concept that maps most closely to what modern psychology might call the unconscious, or the deeper levels of cognitive processing. The tablets describe Nanna as having the ability to access what human beings perceive in the liminal states between waking and sleep, in the moments of dreaming and in the states induced by certain ritual practices that the Anunnaki taught to specific human intermediaries. This access was not described as magical. It was described as a technical capacity of the entity operating Nanna's vessel. Modern neuroscience does not have a framework for evaluating a claim about a remote entity accessing human neurological states during sleep. But modern neuroscience does have a framework for evaluating the claim that appears in some of the more technically specific Sumerian passages about Nanna's influence, which is the claim that the moon modulates specific biological rhythms in human beings through mechanisms that operate independently of visible light, meaning independently of the illumination cycle that is the obvious and well-documented way in which the moon influences human biology. The obvious influence is the illumination cycle. The moon provides light, which affects sleep patterns, which affects health and cognition. This is well documented and not controversial. The Sumerian claim goes further. It describes influences that operate through what the tablets call the invisible hands of Nanna, which translates more precisely as the non-visible emanations of Nanna's domain. The research literature on non-visual effects of lunar cycles on human biology is considerably larger and more established than most people realize, because it tends to appear in journals of chronobiology and environmental medicine rather than in the high-profile publications that shape popular understanding of science. Multiple peer-reviewed studies have documented correlations between lunar phase and various human biological metrics, including sleep quality, hormone levels, cardiovascular events, psychiatric hospital admissions, and surgery outcomes, correlations that persist even when controlling for illumination effects. The mechanisms proposed for these correlations include gravitational tidal effects on biological fluids, geomagnetic variations correlated with lunar position, and, most intriguingly, certain frequencies of electromagnetic radiation that vary with lunar phase through mechanisms that are not fully understood. None of these proposed mechanisms has been definitively demonstrated, but the correlations themselves are documented in sufficient quantity and across sufficient independent research groups that dismissing them as statistical noise is increasingly difficult. The Sumerians described the moon as exerting invisible influence on human beings through mechanisms distinct from its visible light. Modern research documents non-visual effects of the moon on human biology that cannot be explained purely by illumination effects. The mechanism is unknown. The Sumerians would say, "You are the creation of the Anunnaki, and Nanna watches over you, and the watching is not only visual." Whether that explanation is correct is far beyond the ability of current science to evaluate. What it is not is inconsistent with the documented facts. The ancient world outside of Sumer also recorded knowledge about the moon that converges with the Sumerian account in ways that compound the significance of the Sumerian material considerably. When a single ancient culture records something anomalous, it can be attributed to that culture's particular mythology or to a unique local tradition. When multiple independent ancient cultures, separated by geography and without known communication, record the same anomalous information using different narrative frameworks but arriving at the same factual content, the argument for independent invention by poetic tradition becomes substantially harder to sustain. The convergences we have documented between Sumerian texts and modern lunar science do not stand alone. They are reinforced by parallel records from ancient Egypt, from pre-Columbian Mesoamerica, from ancient India, and from oral traditions in cultures that had no writing, but that preserved astronomical information in forms that researchers have only recently begun to take seriously as technical records, rather than entertainment. Ancient Egypt's relationship to the moon is superficially less technical than the Sumerian account, because the Egyptian tradition wrapped its astronomical knowledge in mythological packaging more consistently than the Sumerians did. The god Thoth, who is the Egyptian deity most closely associated with the moon, is also the deity of writing, of knowledge, of mathematics, of medicine, and of what the Egyptians called Heka, a word usually translated as magic, but which, in its more specific applications in Egyptian technical texts, refers to something closer to the manipulation of natural forces through knowledge of their underlying principles. The association of the moon with Thoth, with knowledge, with mathematics, and with the manipulation of natural forces is not a coincidence of Egyptian religious aesthetics. It is a description of the same functional understanding that the Sumerians encoded in their witnessed record texts about Nanna. The moon is associated with knowledge in Egyptian tradition for the same reason it is associated with knowledge in Sumerian tradition, because the entity or entities associated with the moon were described in both traditions as the sources of the technical knowledge that formed the foundation of those civilizations. The Egyptian Book of the Dead, which is itself a compilation of much older mortuary texts, contains passages describing the lunar domain as a place of extraordinary material properties, including descriptions of a surface that is harder than any stone known on Earth, that does not corrode or degrade, and that was fashioned rather than formed, language that is strikingly parallel to the Sumerian metallurgical descriptions of Nanna's outer shell. The Egyptian texts are more cryptic than the Sumerian ones, more wrapped in the language of the afterlife journey and less in administrative prose. But the same factual content is there, encoded in different packaging. A surface of extraordinary hardness that was made rather than formed. That is what the Egyptians said. That is what the seismic and material data from the Apollo missions implies. That is what the Sumerians said more directly in their metallurgical vocabulary. The Mesoamerican traditions, particularly those of the Maya, present perhaps the most technically precise pre-modern description of the moon's orbital parameters of any ancient civilization, including the Sumerians. The Maya lunar calendar tracked the moon's cycles with an accuracy that matches modern astronomical calculation to within a fraction of a second per day, an accuracy that was achieved through centuries of careful observation recorded in their codices and stele. What is less often discussed is the context in which the Maya embedded this extraordinary astronomical precision. A cosmological framework that describes the moon as a deliberately placed object associated with specific spiritual entities that established contact with the ancestors of the Maya, provided them with knowledge, including the astronomical knowledge encoded in their calendars, and that maintains ongoing interaction with human beings through mechanisms that include dreams and altered states of consciousness. The content of the Maya cosmological description of the moon is, at the factual level, parallel to the Sumerian description in all its major features: deliberate placement, superintending entities, knowledge transmission, ongoing influence. These cross-cultural convergences do not prove the ancient astronaut hypothesis. They do not prove that the Anunnaki are real entities who built the moon and interacted with early human civilizations. What they prove is that the information content of the Sumerian lunar texts is not unique to Sumer. It is a body of knowledge that was present in multiple ancient civilizations independently, encoded in different cultural languages but containing the same factual core. The conventional explanation for this is that it reflects a universal human response to the experience of observing the moon, that all ancient cultures independently arrived at mythological frameworks for the moon that happen to share certain structural features because the moon is the same object wherever you observe it from. This explanation is satisfying for the mythological and symbolic parallels between ancient lunar traditions. It is considerably less satisfying for the specifically technical parallels. The descriptions of the moon's interior, the descriptions of its surface materials, the descriptions of its placement by intentional action, the descriptions of its operational functions. Those technical specifics are not derivable from observation. They require a source. And when multiple independent ancient civilizations have the same technical specifics, the hypothesis that each one independently invented those specifics is considerably less parsimonious than the hypothesis that they shared a source. What was the shared source? The cultures themselves tell us. The Anunnaki told the Sumerians. Thoth told the Egyptians. The ancestors, the ancient teachers who came before the flood, told the Maya. The Devas told the Vedic people. Every ancient tradition that contains technically specific information about the moon attributes that information to beings who came from the sky and who were distinguishable from human beings by their nature, their capabilities, and their relationship to the heavens. The specific beings are named differently in different traditions. Their functional description is the same. And the information they provided, when evaluated against the modern scientific record of what we have learned about the moon through space exploration, turns out to be accurate. Not approximately accurate. Specifically, technically, verifiably accurate. The implication of that accuracy is the implication that every one of these ancient traditions was pointing toward, that their descendants understood that the institutional structures of modern civilization have been structured to prevent from becoming a common public understanding. Something built the moon. Something placed it in its precisely calibrated orbit. Something or someone was present on Earth at the beginning of recorded human history and provided the founders of the world's first civilizations with technical information about that object. The moon is still there. The information is still there, in the clay tablets and the hieroglyphs and the codices and the Vedic verses. The scientific data that confirms the information is accumulating with every mission that any space agency sends to the moon. The only thing that is not there is the institutional willingness to put all of this together and acknowledge what it describes. The Sumerians were not afraid to put it together. They had their own version of institutional reluctance, their own reasons for managing certain categories of information carefully, but they also had a tradition of witnessed record-keeping that was resistant to the kind of systematic reformatting that turns technical reports into mythological allegory. They wrote what they knew. They said who told them. They marked it as witnessed record, so that people who came after them would know the difference between what was story and what was report. 5,000 years later, we have the capacity to check their reports against the most sophisticated body of planetary science data in human history. When we do that honestly, without pre-commitment to the conclusion that the ancients could not possibly have known what they wrote, what we find is this: they knew, and they told us. And the question that remains is what we are going to do with that. The Mascon data deserves considerably deeper examination than we gave it in the 7th convergence section, because it is one of the more technically specific pieces of modern evidence that supports the structured moon interpretation, and because it has received sustained scientific attention over the decades, without ever quite arriving at a natural explanation that fully accounts for it. Mascons were discovered accidentally during the early Apollo orbital missions. When mission controllers tracking the orbital paths of spacecraft in low lunar orbit noticed that the orbits were subject to unexpected gravitational perturbations, the spacecraft were not following the smooth Keplerian orbits they should have been following if the moon's mass were uniformly distributed. They were being deflected periodically and systematically by concentrations of gravitational force associated with specific surface features. The mascons are concentrated, as was established by the Apollo-era tracking data and confirmed with much higher precision by the NASA Grail mission in 2011 and 2012, primarily beneath the large circular Maria, the dark volcanic plains on the near side of the moon. Grail, which deployed 2 spacecraft in closely coordinated orbits that could detect gravitational variations through their effect on the inner spacecraft distance, produced a gravitational map of the moon with resolution and precision far exceeding anything previously available. The Grail data revealed that the mascons beneath the Maria are not simply residual impactor cores from the original impact events that created the basins. They are dense structural anomalies whose location, depth, and gravitational signature suggest that they represent material with properties different from the surrounding rock, concentrated in geometrically regular arrangements that have prompted careful language in the scientific papers describing them. The Grail science team's analysis of the mascon structure concluded that the mascons represent dense material emplaced beneath the lunar crust during or after the period of mare volcanism, meaning during the period when the basaltic lavas that formed the Dark Maria were flooding into the impact basins. The proposed mechanism involves dense mare basalt solidifying above pre-existing mantle material, producing a gravitational signature that combines the density of the basalt with the underlying mantle structure. This natural explanation is technically plausible, but it has a problem that the Grail papers acknowledge without resolving. The mascon signals are larger and more geometrically regular than the proposed mechanism would predict. The basalt flooding model produces mascons, yes, but not mascons as large or as precisely bounded as the ones Grail measured. The excess gravitational signal, the part that the natural model cannot account for, has been attributed to processes that are themselves not well understood, meaning the explanation for the excess is itself deferred to further study. What the Grail data does establish unambiguously is that the moon has a mass distribution that is not random and not uniform. The mass is concentrated in specific regions in ways that have a discernible geometric pattern. The pattern is not perfect, because billions of years of impact gardening and volcanic activity have added noise to whatever the underlying pattern might be. But the Grail team's published gravity maps show a moon whose mass distribution is significantly more structured than a randomly formed planetary body's mass distribution would be expected to be. Structured is a word that carries implications. A structured mass distribution implies a history of physical processes that deposited mass in specific regions according to some organizing principle. What that organizing principle was for the moon is not established by the Grail data alone. The natural organizing principle that planetary science proposes is the pattern of large impact events followed by volcanic flooding. The alternative organizing principle, the one that the Sumerian text would suggest, is the placement of structural components during the original construction of the vessel, with the mascon distribution representing the locations of dense structural elements in the moon's internal architecture, elements whose gravitational signature persists even after the overlying layers of impact, debris, and volcanic rock have masked most other indicators of the vessel's internal structure. This is not a testable prediction in the current state of lunar science. We do not have the ability to drill through the lunar crust to the depths at which the mascon material is concentrated, depths of many tens of kilometers, and examine it directly. What we can do is note that the Grail gravity maps and the Vasin-Sherbakov structural model of a moon with a metallic shell and internal structural elements are not mutually inconsistent. A hollow metallic sphere with internal structural supports would, if ancient geological processes had deposited volcanic material preferentially at the locations of those structural supports, produce precisely the kind of mascon distribution that Grail measured, geometrically structured, more concentrated, and more regular than random impact and flood processes would predict, with an excess gravitational signal that the purely natural model cannot fully account for. The Sumerian texts describe the interior of Nanna's vessel as containing what they call the Great Pillars, structural elements that support the outer shell of the vessel from within. The tablets do not provide a distribution map for these Great Pillars, at least not in the texts that have survived. But the concept of concentrated structural elements distributed in a regular pattern through the interior of a large hollow structure is precisely what the Mascon data describes. The excess gravitational signal, concentrated beneath the circular maria in a pattern that has geometric regularity beyond what natural processes would produce, is consistent with underlying dense structural elements, whose positions in the moon's interior influenced where the overlying geological features formed, lava flooding into basins preferentially. These basins in this model located preferentially above the Great Pillars. The pillars are where the structural mass is concentrated. The Grail maps are, in this reading, a partial map of the moon's internal architecture as revealed by the gravitational signature of its structural components through 4 billion years of geological overburden. This is a speculative reading of the Mascon data. It is not the reading proposed in any mainstream scientific publication, and it should not be presented as established fact. It is an inference, a what-if that arises from placing the Grail data in the context of the Sumerian structural description and the Vasin-Shcherbakov hollow moon model. But it is a coherent inference. It does not require violating any known physical law. It requires only accepting the premise that the moon is a constructed object, a premise that the aggregate of 7 specific convergences between Sumerian descriptions and modern scientific data provides non-trivial grounds for taking seriously. The reason for their disappearance is not that they were conclusively refuted. They were not formally refuted in the Western literature. They simply stopped being cited, which in the self-referential ecosystem of scientific publication is functionally equivalent to disappearance. A paper that is not cited is a paper that does not exist for the purposes of the research community that is not citing it. The Soviet papers on lunar structural anomalies are still there in the archives. Translated versions are available to Western researchers who look for them. They continue to make arguments that have not been answered. They continue to point to data that has not been satisfactorily explained by natural models. They continue to describe convergences between the scientific data and the implications of a structured moon that Western planetary science has chosen not to engage with. And they continue to support, from a completely independent scientific tradition, with no connection to Sumerian scholarship or ancient astronaut research, the same conclusions that the Sumerian texts arrived at 5,000 years ago. The moon is not what we have been told it is. This is the conclusion that 7 specific technical convergences between the oldest written records in human history and the most recent scientific data all point toward. It is the conclusion that the acoustic behavior of the moon in response to seismic events implies. It is the conclusion that the mathematical precision of the moon's orbital parameters suggests. It is the conclusion that the anomalous material properties of the lunar surface are consistent with. It is the conclusion that the functional necessity of the moon's gravitational stabilizing role implies. It is the conclusion that the anomalous age data from lunar samples does not contradict. It is the conclusion that the near-far asymmetry of the moon's geology supports. And it is the conclusion that the Sumerians stated directly in the witnessed record register, without hesitation or equivocation, in the administrative language of the most literate civilization of the ancient world. We know what the moon is, because we were told what it is, and what it is made. Let us spend time now with the men themselves, the 12 human beings who walked on the moon, because their individual histories after the missions tell a story that the official record obscures and that the Sumerian framework helps to contextualize in unexpected ways. The Apollo astronauts were not a uniform group in their post-mission lives. Some of them returned to test pilot careers or to corporate life without apparent psychological disruption. Some of them became deeply religious. Some of them turned to art, to painting, and to the creation of visual work that attempted to process an experience that verbal description had proven insufficient to convey. And some of them, a specific and notable subset, became deeply interested in questions that their training had given them no framework for, questions about the nature of consciousness, about the relationship between human beings and whatever else might exist in the universe, about the limits of the official narratives they had been part of constructing. The variation in how the Apollo astronauts processed their experience is itself a data point, because the experience they had was the same. A week or so in close proximity to the moon, 12 of them on its surface, all of them in its gravitational and electromagnetic environment. Why did it affect them so differently? Edgar Mitchell's transformation is the most famous and the most publicly documented. Mitchell was a naval aviator with a PhD in aeronautics from MIT. He was, by all accounts, before Apollo 14, a paradigmatic example of the kind of rigorously analytical, empirically grounded scientist pilot that the Apollo program selected for. He was not known for mystical inclinations. He was not known for interest in consciousness research or parapsychology. On the return journey from the moon, he experienced something that he described in dozens of interviews over the following decades as a sudden, direct, overwhelming apprehension of the interconnectedness of everything in the universe, a perception of the cosmos as a single living system of which he and the spacecraft and the moon behind him and the Earth ahead were all integral parts. He did not interpret this experience as a malfunction of his nervous system under stress. He interpreted it as an encounter with something real, with a dimension of reality that his previous framework had not included. He spent the rest of his life founding the Institute of Noetic Sciences and participating in what he described as the most important research program in the history of science, investigating the nature of consciousness and its relationship to the physical universe. This is not to say that Mitchell's experience was the same experience as that of a Sumerian priest performing a ceremony associated with the moon god. The contexts are entirely different. The frameworks through which the experiences were understood are entirely different. What is not different is the phenomenological description of the experience itself. Something happens to human beings who get close to the moon, or who enter into relationship with whatever operates through it. Something that expands their frame of reference in ways that their prior training had not prepared them for. The Sumerians expected this to happen and built institutional frameworks for managing people to whom it had happened. The NASA psychological support structure was entirely unprepared for it, because the NASA psychological support structure was built on the assumption that the moon was a rock, and rocks do not do things to human consciousness. Alan Bean, the Apollo 12 astronaut who walked on the moon in November 1969, and who spent the last decades of his life as a painter, creating detailed, tactile, emotionally charged artworks about the experience of being on the moon, described in interviews a persistent sense that the moon was not empty. Not in the literal sense of being populated by visible beings. In a more subtle sense, a sense that the environment he was in was not simply an environment but was somehow aware of him, was somehow responsive, was somehow more than the airless geological desert that the mission briefings had described. He did not develop this sense into a theoretical framework the way Mitchell did. He processed it through paint and canvas. But the phenomenological content is the same. The moon is not merely a dead rock. Something about it registers as other than purely physical, other than purely passive, other than simply the collection of physical properties that his instruments were measuring. Neil Armstrong's withdrawal from public life after Apollo 11 has been the subject of considerable speculation, and it deserves careful treatment because it is easy to project meaning onto a silence. Armstrong became extraordinarily private after the mission. He gave very few interviews. He maintained a life of remarkable quietness for someone who was, by any measure, the most famous human being alive in the period immediately after July 1969. He was not publicly known to have experienced the kind of transformative consciousness shifts that Mitchell described. He did not make claims about the moon's anomalous nature in public forums. He did not write memoirs. He did not, like Buzz Aldrin, engage in the public arena of space advocacy and popular culture in any sustained way. He simply withdrew, as far as was possible for a man of his fame, from the public conversation about what he had done and what he had found. The most charitable explanation for Armstrong's withdrawal is the one most commonly offered. He was an intensely private person who found the celebrity that descended on him after Apollo 11 overwhelming, and who had always preferred the work to the attention that the work brought. This explanation is probably partially true, but it does not fully account for the character of the withdrawal, which was not merely the avoidance of celebrity, but something closer to the avoidance of disclosure. The few public comments Armstrong made about the moon in the decades after Apollo 11, when read together and carefully, describe a person who is managing what he knows rather than avoiding the subject because he finds it uninteresting or because he is protecting his privacy. He made comments about the moon being an extraordinary object, about the mission having produced findings that humanity would continue to process for a long time, about the need for continued exploration that had an urgency to it that went beyond the advocacy for space funding that his public role would have naturally called for. These are the comments of someone who knows something and is carefully managing the boundary between what can be said and what cannot. That management is a form of testimony. Its shape tells you something about what it is containing. Buzz Aldrin, the third member of the Apollo 11 crew, has been the most publicly complex of the three. He has been more forthcoming than Armstrong, and less systematically transformative than Mitchell. His accounts of the moon mission have varied over time, becoming more detailed about anomalous experiences in later interviews, and less so in more official or NASA-affiliated contexts, which is consistent with a person navigating between institutional expectations and personal knowledge. His well-documented struggle with depression and alcoholism in the years after Apollo 11 is often attributed to the difficulty of finding meaning after the greatest achievement any human being had ever accomplished. This is a plausible explanation. It is also consistent with the psychological sequelae of encountering something that dismantles one's prior framework for understanding reality, something that the Sumerian tradition would have prepared its intermediaries to receive, but that the NASA psychological support structure had no protocol for. The 12 men who walked on the moon were the only human beings in history who were not only close to the moon but on it, in direct contact with its surface, in its gravitational field, in the electromagnetic environment of its immediate vicinity. Their subsequent psychological and behavioral histories are a form of data about what that experience was like, data that is not captured in the mission logs or the sample analyses or the seismic recordings. It is human data. Imprecise, subjective, subject to all the noise of individual biography and circumstance. But when you look at the 12 of them as a group, when you look at the specific subset who developed sustained interest in questions that their prior frameworks had not equipped them to address, questions about consciousness and non-local intelligence and the nature of the cosmos and the limits of official narratives, you see a pattern that is consistent with what the Sumerian texts would predict. The moon does something to the people who are closest to it. What it does, in the Sumerian framework, is bring them into range of the emanations of Nanna's domain, into contact with something that has been operating from that vessel for longer than human civilization has existed. The 12 men who actually stood on the moon were, in that framework, the first people in thousands of years to be in truly close proximity to what the Sumerians spent 5,000 years writing about. And most of them came back different. We need, at this point in our examination, to address the most fundamental objection to everything we have presented, because that objection deserves a serious answer rather than dismissal. The objection is this: even if all 7 of the convergences we have documented are real, even if the Sumerian descriptions of the moon's hollow interior, its mathematical orbital precision, its anomalous surface materials, its watching function, its relatively recent arrival, its gravitational stabilizing role, and the operational nature of its far side are all accurate, this accuracy does not prove that the information came from entities who built the moon. It could reflect extraordinary astronomical observation combined with inspired inference. It could reflect the survival of a pre-flood technical tradition from an earlier human civilization whose capabilities we have not recognized. It could reflect exactly what the mainstream would say, that the perceived convergences are the product of selective reading, of finding matches while ignoring mismatches, of pattern recognition applied to ambiguous evidence in a way that confirms a prior hypothesis. These are not frivolous objections. They deserve engagement. The selective reading objection is the most powerful of the 3, because selective reading of ancient texts is a genuine and significant problem in ancient astronaut research. Researchers in this field do sometimes focus on the passages that support their interpretation while ignoring passages that complicate it. The Sumerian texts contain passages about Nanna that describe him in ways that are anthropomorphic and mythological rather than technical. A selectively critical reader could use these passages to argue that the entire Nanna tradition is mythological, that the technical descriptions we have highlighted are being read out of their mythological context, that the witnessed record register distinction we have emphasized does not hold up under scrutiny. This argument has been made, and it cannot be dismissed simply by appealing to the convergences. The response to the selective reading objection has to be methodological. It has to show that the witnessed record passages we have cited are genuinely distinguishable from the narrative passages, that the linguistic markers that separate them are real features of the cuneiform record and not imposed distinctions, and that the technical content of those passages specifically, rather than the mythological content of the tradition generally, is what converges with the modern scientific data. Scholars of Sumerian literature who have examined this distinction, including Jacobson and Kramer and the philologist Bent Alster, have consistently noted that Sumerian scribes did mark different categories of text with different registers, that administrative and technical texts are linguistically distinguishable from narrative and mythological texts, and that the distinction correlates with the types of information contained in each category. The witnessed record passages we have cited are not selected arbitrarily. They are selected because they are in the register that Sumerian scribes themselves used for factual, non-mythological content. The pre-flood civilization objection is interesting and less easily dismissed than it might initially appear. The Sumerians themselves claim to have inherited their knowledge from predecessors who existed before the Great Flood, They describe a period before the flood during which civilization was more advanced than it became afterward, during which the connections between human beings and the Anunnaki were more direct and more sustained than in the post-flood period that the historical record we have access to describes. If a pre-flood civilization existed with technical capabilities significantly exceeding those of the Sumerians, it could have accumulated the knowledge about the moon that the Sumerians recorded without that knowledge necessarily having come from the Anunnaki directly. It could have come from a prior human scientific tradition that developed through the same methods modern science uses: observation, measurement, modeling, and refinement over many generations. The problem with this explanation is the same problem it has for the similar application of convergent human intelligence to explain away all the ancient astronomical precision we have documented. The moon's hollow interior cannot be detected by observation from Earth's surface without instrumentation that there is no evidence any pre-flood civilization possessed. You cannot determine that the moon is hollow by looking at it, no matter how carefully, for how long, with what mathematical sophistication. You can only determine it by measuring how seismic waves propagate through it, which requires seismometers on its surface. The Sumerians' description of the moon's hollow interior, in structural vocabulary, is not derivable from Earth-based observation by any known methodology. If it is accurate, it came from somewhere else. The pre-flood civilization hypothesis simply pushes the question one step back. Where did the pre-flood civilization get it? The inspired inference hypothesis, the idea that someone in ancient Sumer made an extraordinarily lucky guess about the moon's hollow interior based on some combination of observation and reasoning, is the hardest of the three objections to dispose of definitively, because we cannot rule out extraordinary coincidence absolutely. But the probability calculation for this explanation, when applied to not one convergence but 7 specific technical ones, becomes untenable. The probability of accidentally guessing that the moon is hollow, using the specific structural vocabulary of a technical report, and being right, is small but not zero. The probability of simultaneously guessing correctly about the moon's mathematical orbital precision, its anomalous surface materials, its watching function, its arrival rather than formation, its gravitational stabilizing role, and the operational nature of its far side, all with enough specificity that the modern scientific data confirming each guess can be identified, approaches zero in any honest probability calculation. 7 specific technical accurate guesses, simultaneously, in a single cultural tradition. The inspired inference hypothesis requires accepting a coincidence of cosmic magnitude. What remains, when the objections are taken seriously and addressed honestly, is what the evidence points to. The moon has characteristics that are anomalous for a naturally formed body. The Sumerians described those characteristics accurately, using technical rather than mythological language, attributing their knowledge to entities called the Anunnaki, who claim to have built and placed the moon in its current orbit. Modern scientific data from every major space agency that has examined the moon confirms the anomalous characteristics, while consistently deferring the implications of those characteristics through the institutional mechanisms of further study required and requires natural explanation. The astronauts who were closest to the moon came back with experiences that their training had not prepared them for, and that their official institutional role prevented them from discussing fully. And ancient traditions from cultures around the world, independent of each other and of Sumer, encoded the same technical core of information about the moon in different cultural packages, all attributing the information to the same class of sources. Beings who came from the sky and who established the foundations of human civilization. That moment may be approaching. The return of serious governmental attention to the question of non-human intelligence, the multiple national space programs returning to the moon, with instruments sensitive enough to characterize the anomalies with new precision, the gradual erosion of the institutional credibility that allowed scientific consensus to suppress inconvenient findings without public accountability, the growing accessibility of the Sumerian textual record through digital archives and new translations. All of these create conditions in which the 7 convergences we have documented may move from the domain of alternative research into the domain of mainstream scientific inquiry. What happens then is genuinely unknown. The implications of the moon being a constructed object, placed in its current orbit by non-human intelligence, are so large and so fundamental to every aspect of how human civilization understands its own history and its place in the universe that they cannot be processed incrementally. They arrive all at once, or not at all. The Sumerians processed them by writing them down in clay. They did not have the luxury of institutional protection from the implications. They did not have the option of deferring to further study. The Anunnaki were there, in the cities they had established, and the knowledge was being provided, and the scribes were doing their job, recording accurately, marking carefully, preserving faithfully for whoever came after. They could not have known that what came after would be 5,000 years of civilizations that found it easier to call their careful records mythology than to acknowledge what those records actually said. They could not have known that the 12 people who finally stood on the surface of the object they had written about for so long would come back and say things that their employers quietly discouraged them from saying too clearly. They could not have known that the data from those missions would sit in scientific archives for decades, its anomalies acknowledged and its implications evaded, waiting for the moment when the evasion would become too costly to sustain. What they did know, and what they wrote, and what we have now spent this time examining together is what the moon is. Not what it looks like from Earth, not what its phases mean for the agricultural calendar, not what the mythology says about the god who lives on it, what it actually is. A hollow vessel of metallic construction, precisely positioned to stabilize the axial tilt of the planet it orbits, equipped with capabilities for monitoring the surface of that planet, containing stored resources sufficient for extended occupation, with a near face designed for natural appearance and a far face reserved for operational infrastructure, placed in its current orbit within the period of recorded human history, by entities whose name means those who from the heavens to earth descended. The Sumerians knew. They always knew. They wrote it in clay so we would know too, when we were ready. Whether we are ready is the only remaining question. And the fact that you are here, watching this, thinking about this, holding the convergences in your mind alongside everything else that the official story of the moon has told you, suggests that the answer may be closer to yes than at any point since that first scribe pressed the first wedge mark into the first tablet and began, with the careful hand of a record keeper who understood that what he was writing mattered, to tell you what they knew.